So this video is going to go over a new set of trig identities known as the Pythagorean identities listed in this red box. So again, just like in the previous video, these are important identities that you should write down in your notebook and you should memorize because you will have to use them over and over again. So the goal is the same as it was in the previous video. What we're trying to do is simplify any expression given to us by using our identities. So far we have our reciprocal identities, our quotient identities, and now we have our Pythagorean identities. Looking at the problem at hand, there are no Pythagorean identities visible, right? So the easy giveaway is in my Pythagorean identities, I have squares, either on cotangents, secants, tangents, sines, cosines, cosecants. I just have a squared somewhere. And if we look at this problem, nothing is squared. So a starting point would not be to use a Pythagorean identity. Instead, we should refer back to the previous identities that we learned, and let's just start by converting everything in this problem to sines and cosines using our reciprocal and quotient identities. So I know cosecant is simply 1 over sine of theta. I also know secant is 1 over cosine of theta, and then I also know cotangent is cosine theta over sine theta. Going from this step right here to this step right here, all that's happened is I've combined both of the fractions on the left-hand side of the equation to become one fraction. So now I have a fraction subtracting another fraction. And we know from Algebra 1 that you can't add or subtract a fraction unless if they have a common denominator. So what I need to do is I need to multiply this fraction by cosine because that's what's missing in the denominator here. Now that I've gone ahead and created a common denominator, I can go ahead and subtract both of these fractions from each other. And what you're very quickly going to notice is I all of a sudden have a Pythagorean identity in my numerator. And in the denominator, again, I have sine of theta, cosine of theta. So what you should realize, hopefully, is if you take the first Pythagorean identity, sine squared theta plus cosine squared theta is equal to 1, and if you rearrange it to give you 1 minus cosine squared, so subtracting cosine squared from both sides, what we see is that sine squared of theta is equal to 1 minus cosine squared of theta. So what I'm allowed to do because of this equivalence statement is I'm able to replace 1 minus cosine squared theta with just sine squared theta. So my new fraction becomes sine squared theta in the numerator divided by sine of theta cosine of theta. Now there's just a little bit more work to be done. If I take my numerator and I rewrite it as individual signs instead of sine squared, this actually becomes sine of theta times sine of theta over sine of theta times cosine of theta. And now we can see that a sine cancels in the numerator and the denominator, which leaves me with sine over cosine. But we should remember that sine over cosine is a quotient identity, which actually equals tangent of theta. So using both reciprocal, quotient, and also Pythagorean identities, we're able to take this equation right up here and turn it into just tangent of theta. Now, it's really important for you to realize that there is no one way to solve any of these trig equations. You simply need to take skills from Algebra 1 on solving equations, and then also your various identities that we learned throughout this semester, and you simply just need to be able to apply them to this equation. There are other ways to solve this same equation. You just have to know which way works best for you. Here we're going to try another trig equation, and again, the goal is exactly the same. We're just trying to simplify here. So taking a quick look at this, we already see that there's no identity that we can apply to this just to begin with. Everything is already in sines and cosines, so I can't really use quotient or reciprocal. And then again, I see 1 minus sine, but this is not squared. I also see 1 plus sine, but this is not squared. So I can't even use any Pythagorean identities. So instead of starting this with identities, we should start this problem using algebra. So looking at this problem, I have two fractions being subtracted from each other. The only algebraic thing that I can do here is create a common denominator. And the easiest way to create a common denominator is simply just multiply each fraction by the denominator of the other fraction. So once I do that, this becomes sine of x times cosine squared of x all over cosine of x times 1 minus sine of x. And then what we should very quickly realize right over here is that this is going to give us a difference of squares because we're multiplying two things together that are conjugates, one with a plus sign, one with a minus sign. So this is going to become 1 minus sine squared of x. And then again, we have this over cosine of x times 1 minus sine of x. Again, what I should very quickly realize is I now all of a sudden have a Pythagorean identity. So again, let me write that out to the side. We know that sine squared of theta plus cosine squared of theta is equal to 1. And if I want to get 1 minus sine squared of theta, I'm going to subtract sine squared from both sides. So now I know that cosine squared of theta is equal to 1 minus sine squared of theta. And again, because of this equivalence statement, 1 minus sine squared, 1 minus sine squared, I can replace this entire thing with cosine squared of theta. Now I'm going to move forward by combining the fractions. So I have sine of x times cosine squared of x minus cosine squared of x all over cosine of x times 1 minus sine of x. So at this point, I can again realize that there are no more identities for me to use. So now I have to go back to using my Algebra 1 skills. If I look in the numerator, I should notice that there is a cosine squared on both sides of this subtraction sign. So what I can do is I should be able to factor out cosine squared. So let's see what that looks like. When I take out cosine squared of x, I'm left with sine of x minus 1, because remember I need my placeholder. And then this is all on top of cosine of x times 1 minus sine of x. I know what you're thinking. You want to cancel these out. And I want to cancel them out too, but the only problem is they're still not exactly the same. This is sine of x minus 1, and this is 1 minus sine of x. Here the negative sign is in front of the 1, and here the negative sign is in front of sine. So what we can do is we can factor out a negative here so that this becomes sine of x minus 1, but then we have to remember to pull that negative out in front of cosine. So let's see what that gives us. So again, on the top, we just have cosine squared of x times sine of x minus 1. And now on the bottom, when I take out that -1 and I put it in front of cosine of x, what's left inside the parentheses is -1 plus sine of x. And what I should realize is that this rearranges to become this, because if I move sine of x to the front and -1 to the back, I get sine of x minus 1. So since these both are equivalent to each other, I can cancel them. So now I'm simply left with cosine squared of x all over negative cosine of x. And just like we did in the previous problem, what I can do is I can expand my numerator. So my numerator becomes cosine of x times cosine of x. And then again, cosine of x is also in the denominator, negative sign. I know that I can cancel one cosine in the top, and I can cancel one cosine in the bottom, giving me my final answer of negative cosine of x. So again, we were able to reach our goal. We took two very large fractions that were all sines and cosines, and we were able to turn it into just this one trig function. To be successful in Unit 5, you really need to pay attention to your Algebra 1 skills. And then you also need to be able to recognize when an identity becomes available in your problem. So far, we've only covered 3 sets of identities: quotient, reciprocal, and Pythagorean. So that's all you're responsible for. But as we move forward, we're going to continue introducing more identities, and it's going to become harder and harder to recognize them. So it's important now that you can recognize them so you get better at it as we move forward. Following this video is more questions where you're solving trig equations. And then after that, you're also going to receive a worksheet from the sub that has more equations that you're going to work on. This module, along with the worksheet, both are due Friday, January 17th. And then when I return, we will go over this more because I know some of us might be struggling.